Today we're going to discuss Chapter 1, Introduction, Matter and Measurements. The learning objectives for this chapter is to distinguish among elements, compounds, and mixture. Also, we will be able to identify symbols of common elements, to identify common metric prefixes. We'll be able to demonstrate the use of significant figures, scientific notation, and the SI units in calculation, and also to attach appropriate SI units to define quantities and employ dimensional analysis in calculation. Chemistry. Why is it important to study chemistry? Chemistry is the study of the properties and behavior of matter. It is central to our fundamental understanding of many science-related fields. So chemistry is basically the base of a lot of different kind of science, because we try to learn how property, what is the behavior, and which are the properties of the matter, and those are important things for other science. So matter is anything that has mass and takes up space. That's the definition of matter. And matter, basically we can have matter just as atoms of an element. We can have matter composed of molecules. Also, we can have, in this case, we have just only one kind of atom. Here we have just one atom, one type of atom in a matter that is composed just of atom, and in a matter that is just composed of a molecule, in this case, also has the same atom. We have two blue spheres here that represent that they are the same. Now, we can have molecules of compounds. Molecule of a compound is a molecule that has more than one different type of element, okay? Compounds must have at least two kind of atoms. We have here one purple and three greens. In this case, this is different as this one because all of them are the same. So here we have molecules of an element, and these are molecules but of an atom. So molecule, basically a molecule is when you have more than one atom attached between them. Okay, so when you have a molecule, that molecule could be composed of just the same atom, and it will be molecules of an element. But if you have more than one type of atom in the molecule, it's a molecule of a compound. And finally, we can have a mixture of elements and compound. Here we have a mixture of all these three atoms and elements and compound. We see here molecules of the same element, and these ones are molecules of a compound because we have more than one type of element there. So matter. Atoms are the building blocks of matters. Each element is made of a unique kind of atom. A compound is made of two or more different kinds of element. Okay, so a compound is made of two or more different kind of elements that we saw before. And here we're going to see some examples. We have here this type of spheres. Most of the time, the white sphere represents hydrogen, the red one represents oxygen, and the black one is going to represent carbon. So here we have a molecule of oxygen. Two atoms of oxygen produce a molecule of oxygen, that is O2. Here, this is the representation of water. It's a molecule of water, of a compound, because we have two different type of elements. We have oxygen and we have hydrogen, two molecules of hydrogen and one of oxygen. Here, this is also a compound, okay, because we have two different kind of different elements, carbon and two oxygen. Ethanol, we have two carbon and basically five hydrogen and one. Actually, it has six hydrogen. We have one in the other side of this carbon, and one oxygen, ethylene glycol, and also aspirin here. So you can see that there's a more complicated type of molecules. But it's the important thing here is that you have all this type of elements, and you can bind them together to create molecules. Okay, so the molecules are basically produced by those combination of different elements. So let's classify the matter. the state of matter. We're going to talk a little bit about the state of matter and also the composition of matter. The state of matter, we know basically three states of matter. We know the liquid, the solid, and the gas. And here we can see all the three states, or at least there's a representation of all those three states for the same molecule. Okay, we're talking here, we can see here the sea, that you have water there. You have here this block of ice that also is water, composed of water, and also in the air you have vapor, water vapor. So we have the three states of the matter represented with the same molecule. In this case, we have water vapor, that is the gas. We have liquid water, that is basically this part of the sea, and also we have solid water, that is the ice. So this is a representation of the three states of matter that we can find. Now, a substance has distinct properties and a composition that does not vary from sample to sample. So a substance basically is, if you have glucose, for example, or sugar, sugar is glucose. So the sugar, it doesn't matter how much you have of them, is going to be basically the same composition. If you have a glass of water or a cup of water, the composition is going to be the same, H2O. So it doesn't matter how big is the sample or how different they are. If you have the same compound, you're going to have the same substance. The two types of substances are elements and compounds. An element is a substance which cannot be decomposed to simpler substances because it has just one element. Okay, so an element is a substance which cannot be decomposed to simpler substances. However, a compound is a substance which can be decomposed to simpler substances. Okay, so we have the element and we have the compound. The compound is a combination of those elements. Compounds have a definite composition. That means that the relative number of atoms of each element that makes up the compound is the same in any sample. And this is known as the law of constant composition or the law of the definite proportions. So that means that we have, for example, here, once again, one element of hydrogen, represented the white sphere. The red one is oxygen. So we can do a combination between these two elements to create one molecule that is known as water, H2O. And H2O is going to have always two atoms or atoms of hydrogen and one of oxygen. Always. It doesn't matter if it's in an ice, if it's in water vapor, or it's in liquid, water as a liquid. In the three matter states, there's going to be H2O. You're going to have always H2O. Now let's talk about the classification of the mixtures. Mixtures exhibit the properties of the substances that make them up. Mixtures can vary in composition throughout a sample, that is called heterogeneous, or can have the same composition throughout the sample, that is homogeneous. In other words, if you can see the parts of for example, you have chicken soup. In chicken soup, you can see there maybe noodles, you can see potato, you can see maybe they have add carrots. So you can see all the elements or all the components of the soup. So that is an example of an heterogeneous mixture. Okay, because it can vary with each scoop you took of that soup. You can have in one maybe celery and chicken, and the other one just noodle. So that composition will vary. So that's why the chicken soup is an example of a heterogeneous mixture. Now the homogeneous could be, for example, a jar of iced tea. The iced tea is, it doesn't matter if you took just a spoon or a cup. You're gonna have the same thing. You can see the difference. You can have different composition between that sample. Okay, so that's a homogeneous mixture. Another name for homogeneous mixture is a solution. So in general, we have matter. The matter can be pure substances or can be mixture. And the pure substances could be element or could be compounds. Here we have an example of a pure substance that is an element. This is a gold, the gold rods right here. And also a pure substance that has compounds. This one is glucose or sugar, basically cubes of sugar, and these are pure substances. Now here we have, for example, the matter as mixture. We have a homogeneous. Here we have a cup of tea, and in a cup of tea you have water, you have the components of tea, you have maybe also sugar, okay? But you can't see the difference in the whole body of that tea. Is just, you can see just one body. You can see all the components on it. So that's why it's a homogeneous. In a heterogeneous mixture, you can see those two components. For example, this is water and this is oil, and they don't mix together. So that's why you can see the two different components of this mixture. And this one is known as an example of an heterogeneous mixture. Okay, so when you can see the components of that solution or that mixture is going to known as heterogeneous mixture. So the classification of matter based on the composition. Matter, the first question you're going to do is if it's uniform throughout. If it's no, now you have an heterogeneous mixture. If it's uniform, it's yes, so you have an homogeneous. Now, does the composition, you have a variability in composition? Yes, so it's a homogeneous mixture. If no, if it's a pure substance. Does the pure substance contains more than one atom? Yes, it's a compound. If it's not, it's an element. Okay, so in that way you can basically define and the matter, okay, through all the different components as a mixture or pure substances. So here we follow that scheme. We're gonna find the homogeneous mixture, that is this one, the heterogeneous, homogeneous this one, heterogeneous this one, the element and the compound. So through this scheme we can determine which type of matter is what we have. Let's talk now about the types of properties. The first one is the physical properties. The physical properties can be observed without changing a substance into another substance. Those examples that we have is boiling point, density, mass, or volume. So these are physical properties. We can measure them without inducing any change of the substance. Now we also have the chemical properties, and this can only be observed when a substance is changed into another substance. Some examples of this is flammability, because when you burn something, you are changing that matter to another type of matter. Corrosiveness or reactivity with acids. So if somehow the first matter that you have go through a chemical change or a chemical basically reaction, that is a chemical property. Okay. We also have different types of another type of property that is called intensive property. The intensive properties are independent of the amount of the substance that is present. So it doesn't matter how much you have of that substance, this characteristic, this property is going to be the same. For example, the density, the boiling point, or the color. So for example, let's talk about the boiling point. The boiling point is a temperature when you can go from liquid to gas. Okay, when you boil water, for example, at 100 degree. So it doesn't matter if you boil a cup of water or if you boil a gallon of water, the boiling point, the temperature at which the liquid will be transformed to gas is going to be 100 degrees. So that's why it's an intensive property, because it's independent of the amount. The boiling point is not dependent of the amount. So that's why it's classified as an intensive property. The second one, type of property is extensive property. This one is depend upon the amount of the substance present. So this one depend for example, the volume, the mass, or the energy. They're going to be dependent on how much you have of each substance. Another type of change is the physical changes. Are changes in matter that do not change the composition of substances. So this one basically include changes of state, temperature, and volume. So physical changes are the ones that does not change the composition of the substance. And the chemical changes results in new substances. Example include combustion, oxidation, and decomposition. So these are the two different changes that we have. We have physical changes and chemical changes. So for example, if you go from ice water to liquid water, that's a physical change, because it's gonna be still be water. You have H2O as a solid or H2O as a liquid. So that's why it's a physical change. In the chemical change, you're going to transform completely that molecule. So that's why is known as a chemical change. So change in state of matter. Converting between the three states of matter is a physical change. When ice melts or water evaporate, there are still two hydrogen atoms and one oxygen atom in each molecule. So if you go, for example, from the liquid to the gas, you're going to still have the molecule of water. Okay, you can see here the molecules of water here in the liquid, and when they transform to gas, the vapor are going to have the same molecule. The same thing happen if you goes from the vapor to the solid. Okay, you're going to have here the vapor, water, and as a solid, the ice, you're going to still have those molecules of water. So in the physical change, there is no change of matter, of the composition of the matter. So let's talk about some characteristics of the state of matter. Let's talk about the solid first. In solid matter, atoms or molecules pack close to each other in fixed locations. Neighboring atoms or molecules in a solid may vibrate or oscillate, but they do not move around each other. They doesn't move freely, okay, in a solid. The most that you can feel or see or determine is just a little bit of vibration or oscillation. Solids have fixed volume and rigid shapes. The liquid, in liquid matter, atoms or molecules are close to each other but are free to move around and by each other. So they move a little bit more than in a solid, and they also have fixed volume because their atoms are or molecules are in close contact, but as different as a solid. The liquids assume the shape of their containers because the atoms or molecules are free to move relative to one another. So that's why they have this characteristic that they can assume that shape of the container that the water will be in. So as it's different from the solid has a specific shape, okay, but the liquid is going to be depend on the container that it has, the liquid. And the third state of matter is the gas. In gaseous matter, atoms or molecules are separated by large distances and are free to move relative to one another. Since atoms or molecules that compose gases are not in contact with one and another, gases are compressible. Gases always assume the shape and volume of their containers. So they are similar as a liquid because they basically has assume the shape of the container. Okay, but they are different from the solid also because these atoms are more freely to move. They can go through all basically all the space of the container that they have, where they are. And also a very important characteristic is that the gases are compressible. What are compressible? Since the molecules or atoms or molecules that compose gases are not in contact with one another, gases can be compressed. So here, if you try to press a solid, you can because it doesn't have space between those molecules. But if you try to compress the gas, you're gonna have a lot of space, so you can move this piston down and increase that pressure and create that compression on the gas. Chemical reactions. In the course of a chemical reaction, the reacting substances are converted to new substances. Here, the elements hydrogen and oxygen become water. Okay, so here we have the combination of H2 hydrogen and O2 oxygen. When you combine them, you're going to produce water. In a chemical reaction, we're always going to see like an arrow like this one, and at the left side of that arrow we're going to have the reactants. These are reactants, and in the right side of this arrow, these are we're going to find the products. So these two reactants, hydrogen and water and oxygen, will react and will produce the molecule of water. Okay, the product and the reactants at the left of this arrow. So what about if we want to separate a mixture? Do we have tools to so we can separate the components of a mixture? And the answer is yes. Yes. Mixtures can be separated based on physical properties of the components of the mixture. Some methods that are commonly used are the filtration, distillation, and chromatography. And we're going to discuss a little bit, we're going to talk a little bit about each of them in the next slides. Filtration. In a filtration, solid substances are separated from liquid and solution. So here we can see that we have here a solution, okay, that has solid and liquid. We pour this here in through filtration. This is a filter, and in this beaker, we're gonna collect all the liquid, and the solid is gonna stay in the filter. So filtration most of the time is used so we can separate the solid from the liquid. The second one is distillation. In distillation, uses differences in boiling points of substances to separate an homogeneous mixture into its components. So here we can have, for example, a composition of a mixture of water and alcohol. Okay, both of them are going to be liquid, and you're going to see just a homogeneous solution. And we can use the difference in boiling point, so we can have that as an advantage, so we can separate these two components of that solution. So here we're going to have, for example, in this case is salt water. We're going to boil the solution to vaporize the water, and the water as a gas is going to go through this basically this system, okay, and the gas is going to go through the condenser. This condenser has a jacket, okay, what goes cold water through that jacket is not in contact with the inner part of the tube, okay. The gas is going to go through like a tunnel inside here, and outside that tunnel is this jacket, okay, this jacket with cold water that's going to condense, is going to make that gas to goes to liquid, and you can collect here that water, the water that was evaporated from here. Okay, so here once again we have the mixture. We start to add heat, and the water is going to transform from liquid to gas. It will go through this tube, okay, to this system, and when it goes to the condenser, the water, cold water that is in the jacket of that condenser, is going to cool that gas, and it's going to decrease the speed of those molecules, and it's going to produce here the liquid, and in that way you can basically collect the liquid. The third one, basically after, and also after water has boiled away, you're gonna have here the remains of the solid that was the salt in this case. The third kind of technique that we can use to separate components of a solution or a mixture is the chromatography. In this one, we can separate the components of a mixture by using the ability of the substances to adhere to the solid surface. We are going to use a column here that has, this one is the stationary phase, the one that is going to be able to separate those components of the mixture, okay? And we're going to add on the top of that column the mixture, and here we're going to add the solvent that is going to help to move the mixture and all the components through this absorbent, and allow the absorbent to interact with the different components in different way, and that will help to separate those three components, okay? So we're going to have a column with the absorbent here, the stationary phase. We're going to add the mixture, the sample on top of that column, and then we're going to keep adding the solvent, and when we start to add the solvent, we can't allow this to dry, so we need to keep always adding more solvent until we finish the run of the chromatography. So once this start, okay, we open here and we're going to start to collect solvent first, because it's the only thing that's going out. We're going to have here the component 8, and here is going to be B plus C, okay? And then we're going to see as time goes by that B and C are separate also, and the three different components, and in that way the chromatography help us to separate those components of the mixture. Because this, for example, the 8 has a major affinity with the column. It has going to be more time because you're going from top to bottom. So the C, it has less interaction with that stationary phase. So that's why it's going to start go out first. Then the B is going to be number two, and letter A is going to go out as a third component. Okay, so in that way, this is how that chromatography works and help us to separate the different substances of a mixture. And most of the time, it helps for homogeneous mixture because those are the hardest to separate. Now, let's talk about numbers in chemistry. Numbers plays a major role in chemistry. Many topics are quantitative, so we need to uh, quantify something, and to quantify, we need to express that using a numerical value. So we're gonna talk about different concepts of numbers in science. For example, units of measurement, quantities that are measured and calculated. Also, uncertainty and measurements, significant figures, and finally, the dimensional analysis. So first, we're going to talk here about the different units of measurement, the SI units. This is basically the system, international system, the SI units. So for physical quantities, the mass, most of the time we're going to use the kilogram. The abbreviation is kg. Length is meter, small m. Time, the units for time is second. We can use the S or the 3 SEC, sec for second. The most common or the basic units of SI for temperature is the Kelvin, that is K. The amount substance is mole, and we can represent this by the abbreviation of MOL. For electric current, the unit that we use in SI system is the ampere, or you can use the A or AMP. And the last one is the luminous intensity, candela, that you can use the CD. So these are the most important units, okay, well, basically the units for the physical quantities based on the system international. So you need to learn this and identify them, okay, and know when you can use them. So for example, we can also talk about the metric system. The base units used in the metric system, for example, gram, okay? When you are talking about mass, is the gram. When we're talking about length, is meter. We're talking about time, is going to be second. And we're talking about temperature, is going to be the Kelvin. Substance mole, volume is going to be liter or cubic centimeter. These are the metric systems, okay? As different as, for example, the international one that in the mass use kilogram, okay? So here we have used grams. So the metric system, the mass is going to be gram, length meter, time second, temperature degrees Celsius or Kelvin, amounts of substance moles, and volume is going to be cubic centimeter or liter. These are basically the units for the metric system. Also, here you have a table of the unit of the metric system prefixes. The prefixes convert the base units into units that are appropriate for common usage or appropriate measures. So these are basically different prefixes that we use to express very large amount or numbers or very small numbers, okay? So instead, we can have here, let me also point this out. You're gonna find sometimes red numbers in this side. So those are numbers of exercise that you can find in the book that are related with the topic of each slide. So some of the time you're gonna see this number, so you can go to 1.25 and 1.26, so you can practice some exercise based on this concept that maybe they're gonna come in the test. So we're gonna talk a little bit more about the metric system later. Now let's talk about the mass and the length. These are basic units we measure in science. Mass is a measure of the amount of material in an object. SI uses the kilogram as the unit base, and the metric system uses the gram as the base unit, as we mentioned before. The length is a measure of distance. meter is the base unit, okay, in the case of the length. The volume, note that the volume is not a base unit for SI. It is derived from the three measurements of height, depth, and length. Okay, meter times 3 is going to be meter cubic. The most commonly used metric units for the volume are the liter and the milliliter. A liter is a cube 1 decimeter long on each side. So basically, a liter is a cube with 1 decimeter long for each side of that cube. A milliliter is a cube of 1 centimeter long on each side, also called 1 cubic centimeter. Also, so that means that 1 milliliter is equal to 1 centimeter cubic. Okay, that's one definition. Here we can see that here. 1 centimeter cubic is equal to 1 milliliter. Another, I'm going to talk also about the temperature here, the measurement that we use. In general usage, temperature is considered the hotness and coldness of an object that determines the direction of the heat flow. Heat flows spontaneously from an object with a higher temperature to an object with the lower temperature. Okay, always you're going to go from the heat is going to be transferred from the object that has a higher temperature to the object that has the lower temperature. And here we have the different scales. The Kelvin scales that goes from 273 degrees Kelvins to 373 Kelvins. The Celsius, this is the most common that we have used is 0 to 100. And science, most of the time we use the Kelvin. Okay, the Celsius go from 0 to 100, and this same range is for Kelvin scale from 273 to 373. Okay, so this correspond to this scale on Celsius. When Celsius go from 0 to 100, Kelvins go from 273 to 373 Kelvin degrees. And Fahrenheit, when Celsius is 0, Fahrenheit is 32 degrees. And when you have a 100 degrees Celsius, that represents 212 degrees Fahrenheit degrees. So in scientific measurements, the Celsius and Kelvin scales are most often used. The Celsius scale is based on the properties of water. So the freezing point of water is 0 degrees and the boiling point of water is 100 degrees. So that's basically the range, okay, for the Celsius scale. The properties of water. The Kelvin is the SI units of temperature. It is based on the properties of gases. There are no negative Kelvin temperatures. The lowest possible temperature is called the absolute zero. So you're never going to find a negative temperature in Kelvin. You can find in Celsius and also in Fahrenheit, you can find negative temperature, but Kelvin is going to be always positive. It goes from 0 to 373 degrees, basically, or more. So, and there's an equation, okay, that relates Celsius and Kelvin, and it's this one. So if you have the temperature in Kelvin, you can add 273 degree 0.15, and you're gonna find out the Kelvin temperature. If you have the Kelvin temperature, you can find the Celsius by subtracting from the Kelvin 273.15. So this one is really important to know this equation, but also know how to use it. Also, we have the Fahrenheit scale is not used in scientific measurement, but you hear about it in the weather reports. Most of the time, they use the Fahrenheit scale. The equations below also help us to go from Celsius to Fahrenheit or from Fahrenheit to Celsius. So you can just learn one of this and then you can find out the other one, or just maybe memorize both of them. But you need to know how to use them. It's really important to know how to use them, so that you have the three different equations that can relate Celsius, Kelvin, Fahrenheit, Celsius, Celsius, Fahrenheit. So it's really important to learn those equations. Now let's talk about another property that is known as density. The density is a physical property of the substance and is very characteristic of each substance. It has units that are derived from the units of for mass and volume. The most common units are grams per milliliter or grams per centimeter cube, cubic centimeter. As we mentioned before, 1 milliliter is equal to a cubic centimeter. Okay, so that's why these are basically the same units. And the equation for density, density is equal to mass over volume. This equation, again, it has three variables: density, mass, and volume. So if you have two of them, you can determine the third one. So this equation is not just to determine the density. You can use it also to determine the mass or the volume if you have the other two variables. So if you have the density and the volume, you can calculate the mass. If you have the density and the mass, you can calculate the volume. And if you have the mass and the volume, you can calculate the density. And we need to rearrange this equation in a way to determine whatever we need. If we need mass, it's going to be density times volume. If we need volume, it's going to be mass divided by density. So you may play with this a little bit to know how to rearrange this equation in a way to obtain density, to obtain mass, and to obtain volume. And also, these are some examples that you can go there to your book and work on them that are related about or are about basically density. So also we're going to see an example here, how to calculate density. We calculate the density of a substance by dividing the mass of a given amount of the substance by its volume. So for example, a sample of liquid has a volume of 22.5 milliliters and a mass of 27.2 grams. To find its density, we need to use the equation density is equal to mass over volume. So we divide the mass, that is 27.2, by the volume, that is 22.5 milliliter, and that will be the density. So we have here density equal to mass over volume. We substitute this to value, the mass 27.2 grams, the volume 22.5, and this will be equal to 1.21 grams over volume. Okay, mass over volume, grams over milliliter, mass over volume. So this basically is the density for that liquid. Now let's talk about some strategies to basically solve some mathematical problems. The first thing is identify the starting point. What information you can find in the problem. That's the first part. Then you need to identify the end point. What is the question? What are you looking for? Okay, so those are really two very important things. It maybe looks like, it's like, hello, that's what you're looking for, whatever. But it's important to identify them because in a problem, you're going to have a lot of information. So you need to be able to identify what are that information that you have at the beginning and where you want to go. What is the question? What are you looking for? And then devise a way to get from the starting point to the end point using what is given as well as what you already know or can look up. Okay, so not all the information that you need is going to be in the problem, though you can have some of those information in your mind, or maybe you can need to look up for that information. You can use a solution map to diagram the steps required to get from the starting point to the end point. In a graphic way form, we can represent this progression as the information, the data given at the starting point. The solution map is what you're going to do so you can find, okay, whatever they are asking in the problem. So in other words, sort is the beginning by sorting the information in the problem. Then do the strategy, okay, by creating a solution map. That is a series of steps that will get you from the given information to the information you're trying to find. Okay, this is it's the same thing as if you're going from your house to a Starbucks, okay, and you need to create a map. I'm gonna turn left in this light. I'm gonna go straight forward. Then in the next stop, I'm gonna make a right, and those are the series of steps that you need to go through so you can get to the Starbucks. So this is the same concept. Okay, it's a map that you need to create to solve the problem. So the third part is going to be solve, that is carry out the mathematical operations. paying attention to the rules for significant figures in calculation. We're going to talk a little bit about that later. And cancel unit as needed. And finally, you're going to check, does this answer make physical sense, or are these unit correct? Okay, so those are questions that you're going to ask at the end of the problem. So basically, this is the strategy that we suggest you to do in any problem from now on. So a solution map is a visual outline that shows the strategic route required to solve a problem. For unit conversion, the solution map focuses on units and how to convert from one unit to another one. So the units also can be very helpful, so you can know where you are in the map and also what you need to do next in a way to go to the next step. Okay, so sometimes those units helps a lot. So a solution map involving the equation for density. Let's do an example for this. In a problem involving an equation, the solution map shows how the equation takes you from the given quantities to the defined quantity. So here we have, for example, mass and volume. We want to determine the density, so we start with this and we're going through this using this equation, mass over volume. So this is the initial data that we have. We need to create or find out a mathematical operation that's going to help us to determine that variable that we're looking for, that in this case is the density. Now let me introduce you to a concept that is known as a conversion factor. We can use the density of a substance as a conversion factor between the mass of the substance and its volume. A conversion factor is a tool that you're going to find very, very useful because it's going to help you to go from one unit to another one. That is why it's known a conversion factor. That factor help you to go from the unit A to unit B. Okay, so we're going to see that density, for example, it can be used as a conversion factor, and we're going to see other conversion factors a little bit later. So in this case, let's see this example. For a liquid substance with a density of 1.32 grams over cubic centimeter, what volume should be measured to deliver a mass of 68.4? In this one, we have the density, we have the mass, so we can calculate the volume. Now, here you can see grams over cubic centimeter. Every number is a fraction. Every number is a fraction. This number here, 1.32, is a fraction. The number that is in the bottom part of 132 is 1. So you don't represent that like 1.32 over 1 because that is 1.32. But you need to remember that you have a 1 below the 1.32. So that means that you have 1.32 gram over 1 cubic centimeter. Okay, you have 1.32 gram over 1 cubic centimeter. So that means that we can represent this as this. Okay, but also we can flip this and have this. So from here we have 1.32 grams over 1 cubic centimeter, that is this one, or we can flip this and put the 1 centimeter cubic on top and the 1.32 grams on the bottom. So from this one, we're going to have two conversion factors. This is one conversion factor. This is another conversion factor. And they both came from the same source, okay? That is the density. So from one density, you can obtain two different conversion factors. And you're going to use the ones that you need to cancel your initial unit. So your initial unit was mass, the gram. So you need to use the conversion factor when you can find this unit in the bottom part. So from these two conversion factor, the one that we need is this one, 1 cubic centimeter over 1.32 grams. So in that way, we can cancel the unit of mass. So here we have actually, yeah, okay. So here we have the mass. Okay, from mass we can go to centimeter square using the density over 1.32 grams, and we can have canceled the units of gram here, and we're going to have the centimeter cubic, but we want to express this in milliliter, for example. So then we find another conversion factor that is going to convert from cubic centimeter to milliliter. And this one is a definition, because we knew from a few slides before, we mentioned that 1 milliliter is equal to 1 cubic centimeter. Okay, so that definition also can create two conversion factor: 1 milliliter over 1 cubic centimeter, or 1 cubic centimeter over 1 milliliter. So always, any definition, you're going to find two conversion factor. It's going to produce always two conversion factors. And you're going to use just one, the one that you need to cancel your previous unit. Okay? So in this case, we have this result here is in centimeter, cubic centimeter. So we want to cancel the cubic centimeter. So we're going to use this conversion factor as it is here. So we can cancel the units of centimeter, and at the end, use the unit of milliliter. So 68.4 grams. This is the initial data that we have in the problem. We use the two conversion factors. So here we have, I'm sorry about that. The first one is going to cancel the unit of mass, okay? Like that. And we're going to have now the unit of cubic centimeter. But we need to have the milliliter unit, so we're going to use this second conversion factor. So in that way, we can cancel the centimeter cubic, and then we're going to represent our result in the units of milliliter. So measure 51.8 milliliter to obtain 68.4 grams of the liquid. So in a sample of 51.8 milliliters, that volume represents a mass of 68.4 grams. Let's talk now a little bit about numbers. Exact numbers are counted or given by definition. For example, there are 12 eggs in 1 dozen. You can count eggs, so that 12 is an exact number. Okay, and also a definition of 1 dozen is equal to 20. The 1 and the 12, both of them are exact numbers because they are definition. Inexact or measured numbers depend on how they were determined. Scientific instruments have limitations. Some balance measure to the second decimal place, and others measure at the fourth decimal place. So these are two different measurements, okay? So whenever you measure something, volume, length, mass, whatever you need to use an instrument to determine a quantity, that number is an inexact number, is a measured number. It's going to have always an error, okay, because it's not an exact. You use something to measure, you use an instrument to measure that quantity, and all the instrument has errors. So that's why at the end, when you measure whatever you're going to measure, the length or the mass or the volume, that number always going to have an error. It's not an exact number. So let's talk about uncertainty in measurements. Different measuring devices have different uses and different degrees of accuracy. All measured numbers have some degrees of accuracy. Here we have different instrument. This is the graduate cylinder. This is the syringe and the burette. This can have used to measure volumes. Also pipettes and volumetric flask. This also has basically all of this. It doesn't matter how exact they will be. The measure that you're gonna obtain, that value is gonna have always an error. Always, always. So let's talk about accuracy and precision. Accuracy refers to the proximity of measurements to the true value of a quantity, while precision refers to the proximity of several measurements to each other. So accuracy is how close you are about the real value or the true value, and the precision is how many times you are close to a specific value. It doesn't matter if it's the true value, but it could be on any kind of value. Okay, so for example, here we have the dart table, and this represents a very high accuracy and precision, because both you have accuracy because you're hitting the bullseye, and good precision because all of them are hitting close to that, basically the bullseyes. This one, what represents this one? What do you think about accuracy and precision? The accuracy is not that good because this is the real value here. Okay, so they are pretty far away from this value, so it doesn't have a good accuracy, but it's a good precision because they're hitting basically the same spot always. Okay, so this is an example of poor accuracy but good precision. And this one is poor accuracy and also poor precision. So let's talk now about significant figures. The term significant figures refers to digits that were measured. Whenever you measure something, you need to determine the significant figures. When rounding calculated numbers, we pay attention to significant figures so we do not overstate the accuracy of our answers. And we need to discuss some rules for the significant figures. First of all non-zero digits are significant. Second, zeros between two significant figures are themselves significant. Third, zeros at the beginning of a number are never significant. And zeros at the end of a number are significant if a decimal point is written in the number. If you have a decimal point after the zeros, those zeros are significant. Okay. When addition or subtraction is performed, answers are rounded to the least significant decimal place. And when multiplication or division is performed, answers are rounded to the number of digits that correspond to the least number of significant figures in any of the numbers used in the calculation. So if we are in addition or subtraction, we need to look for the decimal places, okay, in those initial numbers. If we are doing the multiplication and division, then we need to identify the significant figures of each of the initial data so we can represent our final answer in the least number of significant figures. This is when you multiply or are using division, okay, in a mathematical operation. So rules for rounding. Use only the last or leftmost digit being dropped to decide in which direction to round. Ignore all digits to the right of it. Okay, round down if the last digit drop is 4 or less. Round up if the last digit dropped is 5 or more. Those are the rules for rounding. Okay, if it's 4 or less, you don't have to you just run down. It just stays like that. And if 4 or more, 5 or more, you need to round up. So multiplication and division. The result of multiplication or division, as I mentioned before, carries the same number of significant figure as the factor with the fewest significant figures. So for example, here we have a multiplication of 5.02 times 89.665 times 0.10. So if you use a calculator, the result is going to be basically, we can find out here that we have three significant figures. Okay, this zero is between two non-zeros numbers, so this zero is significant. We have 1, 2, 3 significant figures. All of these are non-zero, so all are significant. We have 1, 2, 3, 4, 5. And here we have 1 0, a 1, and another 0. this 0 is non-significant. This 0 is significant. So we have two significant figures. When we represent and we would do the calculation, we have this result, 45.0118. But we need to represent this with the same number of significant figures as the last one that has the fewest in our initial data. So 352, that means that we need to represent this as two significant figures. We need to remove this number, drop this number, okay? And at the end, our result is going to be 45. So this is the representation of how you express the results of this operation. Two significant figures. The intermediate results in blue is rounded to the two significant figures to reflect the least precisely known factor, that is the 0.10. This one is the least precisely factor, which has just two significant figures. What happened when we are doing the division? 5.892, 6.10. How many significant figures we have here? 1, 2, 3, 4. And here, 1, 2, 3. This 0 also is significant. So we have 4 significant figures, 3 significant figures. Whatever is our result, we need to express that result with 3 significant figures. So our result is 0.96590. So that means 3 significant figures will be 1, 2, and 3. This is going to be the last one. So we drop these numbers, but this number is higher than 5. So that means that we need to round up that 5 to 6. So our final result is going to be 0.966. The intermediate results in blue is rounded to the 3 significant figures to reflect the least precise number as 3, as we mentioned before here. And also we round up because this number that was dropped is higher than 5, so we need to add 1 to the last number that is going to be part of the right answer. Now, what about addition and subtraction? In addition and subtraction, the result carries the same number of decimal places as the quantity carrying the fewest decimal places. So here, we're going to look for the decimal places, not the significant figures. You're going to look out for the significant figures when you're doing multiplication or division. If we are doing subtraction or addition, we're going to look for the decimal places. So here we have an example, 5.74 plus 0.823 plus 2.651. This has 2 decimal places, 3 decimal places, 3 decimal places. So that means that the ones with the fewest decimal places is this one. So we need to express our result in 2 decimal places. Okay, so that's why the result is going to be 9.21. We round the intermediate answer in blue to 2 decimal places because the quantity with the fewest is 5.74. That has also 2 decimal points. In subtraction is the same concept. We have here 4.8 minus 3.965. We need to express the result in 1 decimal place because this is the one with the fewest number of decimal places. So that's why we have here the 0.835 and the result is going to be 0.8. Remember that we need to look for the first number that's going to be dropped. If that number is 4 or lower, you don't do nothing. Just keep this number as intact, okay? So it doesn't matter this 5. Don't get confused. This 5 is not going to be significant. So this is the one that you need to see, the 3. And in this case, the 3 is lower than 4. So that's why you just drop this number and keep the other one. So the result is going to be 0.8. So what happens when we have both multiplication, division, and addition or subtraction? What are the rules there? In calculation involving both multiplication, division, and addition, subtraction, do the steps in parentheses first. Determine the correct number of significant figures in the intermediate answer without rounding, and then do the remaining steps. Okay, so this basically you're going to work first with the parentheses, and then remember to keep those significant figures to use it eventually later in the problem. So for example, here we have 3.489 times parentheses 5.67 minus 2.3. So we need to solve first the parentheses. 5.67 minus 2.3 is a subtraction. So we need to look for the decimal places. Here we have 2 and here we have 1. Okay, so it's going to be 3.37. We need to keep, we usually you can draw a line under the number with the significant figures that you need to keep or the decimal place. And then you multiply, basically use the subtraction rule to determine that the intermediate answer has the only one significant decimal place. To avoid small error, it is best not to round at this point. Instead, underline the least significant figure as a reminder. Okay, and then you multiply this value 3.37 times 3.489. Now here, this is an operation of multiplication, so we need to look for the significant figures, no more decimal places, because we use them to calculate here where we're gonna basically round this number, but we're gonna keep them until the end, but with the mark that we need to keep in mind that this is two significant figures. So here we have 1, 2, 3, 4 significant figures, and here we're gonna have 1 and 2. This is not significant. Okay, so we have two significant figures here, 4 here. So we need to express that to two significant figures. So this will be 11.758 is the result of this multiplication. So we need to drop all these numbers, but because 7 is 5 or higher, we add 1 to this number 1, and our final result is going to be 12. Now let's go back to our dimensional analysis. And remember that units are multiplied, divided, and canceled like any other algebraic quantities. Okay, so the unit has the same, basically goes through the same mathematical operation as the numbers per se. Using units as a guide to solving problem is known as dimensional analysis. Always write every number with its associated unit. All numbers needs a unit in a problem, so even the results needs to have the unit. Always include units in your calculations, dividing them and multiplying them as if they were algebraic quantities. Do not let units appear or disappear in calculations. Units must flow logically from beginning to end. For most conversion problems, we are given a quantity in some units and asked to convert the quantity to another unit. These calculations take the form of the information given times the conversion factor or factors, because sometimes we're going to need more than one, and this is the information sought. So the given unit is going to go through the conversion factor. We're going to cancel this unit with the one in the bottom. Remember that we mentioned that we can create two conversion factor from one definition, and the one that we're going to use is the one that has the given unit in the bottom, so we can cancel them. Because if you put it in the top, you're going to multiply both unit and you're going to be squared instead of cancel them. Okay, so that's why you need to use your conversion factor in a way that your given unit is going to be in the bottom part, so you can cancel with the given unit that you have at the initial, and then the desired unit is going to be left as to use in the result. Conversion factors are constructed from any two quantities known to be equivalent, known as definition. As we mentioned before, the 2.54 centimeter is equal to 1 inch. So we construct the conversion factor by dividing both sides for an equality of 1. I mentioned that every number is a fraction, so we put a 1 in each side. And we're going to have here that 2.54 centimeter is equal to 1 inch, and this is one conversion factor. Okay, so the quantity of 2.54 centimeter over 1 inch equal to 1 and can be used as a conversion factor. And also, as I mentioned before, we can basically also flip that number. So we can use 2.54 centimeter over 1 inch, or 1 inch divided by 2.54 centimeter. Depends on our starting unit. In solving problems, always check if the final units are correct and consider whether or not the magnitude of the answer makes sense. So for example, here we have 44.7 centimeter. We want to turn this to inches. So we use this conversion factor. This is the inverse of the one that we saw before. Okay, as I mentioned, we can flip them. So we have here the centimeter in the bottom. We need to cancel that unit. And now we have the inch on top. So the final result is an inch. This number has 3 significant figures. These are exact number. Okay, so this has infinite significant figures. So your result is going to be expressed with the significant figures of your initial data. Here we have 3, so we're going to have 3 significant figures in a product. This is a multiplication, so with significant figures. Conversion factors can be inverted because they are equal to 1, and the inverse of 1 is 1, so that's why we can invert the conversion factor. So therefore, 2.54 centimeter or 1 inch is equal to 1, and also 1 inch over 2.54 is basically the same. So that's why one definition always is going to produce you 2 conversion factor, always. So in review, we basically we learned why to study chemistry, the classification of matter. We talk about the properties of matter, the units of matter. Also, we saw the uncertainty in measurements, and we make some examples of the dimensional analysis. So this will be all for chapter number 1, Introduction, Matter, and Measurements.